Okay, I will switch on the camera for a short moment that you can see me. And beside me is Sabine Frey. She will give an example how to use the precautionary matrix on for a special process.
So Christof, you should have to accept your screen invite, and that's
yes.
Now we can see your screen.
Okay, great.
There's nothing on it, but we can see your screen.
Okay, now.
Yes, now.
Okay, great. Well, now I will give a short introduction into the precautionary matrix, and Sabine will then give a case study made by the precautionary matrix. This is the agenda. You have already seen that, and so I will just start with my presentation. What's the precautionary matrix? It's a control banding tool based on a limited number of parameters. So it can be applied early in the safe by design process. It is generally applicable, and it gives an indication of where a need for precautionary measures exists. It can also help to detect knowledge gaps and risk potentials for workers, consumers, and the environment. But you have to keep in mind the precautionary matrix does not replace risk assessment. So, as it has already been said by Andrea, it can be applied along the value chain, starting from research and development, primary production and processing, up to consumption and use and disposal. It can be used for nanomaterials, but also for products containing nanomaterials. Here you can see the setup of the precautionary matrix. The matrix has 3 different modules. The first one is the context module, which you are seeing here. In the context module, the nano-relevance will be clarified. We will come to this later on, and after that you have to answer some question about the current state of knowledge. If you don't know everything, this will give you penalty points, and this will also be reflected in the results of the precautionary matrix. You see here information, and here you can see how this is treated in this equation. It will give some extra points. Then the second module is the potential effects module. The parameters used here are reactivity and stability of the nanomaterial. I will come back on that. And the third module is the potential for human exposure, the potential emission into the environment. We'll explain this later on. In these 2 modules, scores are given for each of the parameters used in these modules. The highest score is 9. And this means that you have a higher reactivity or stability. The score 1 means that you have a low reactivity or stability. And then with these scores, the matrix is using this equation for calculating the precautionary need. So the higher the precautionary need is, the higher is the number you will get, and if you have a high number, there's a need to look to have a close look at the risk situation. So here is the module about the nano-relevance. It has 2 different entry gates to the precautionary matrix. One is you probably know, it's the EU definition, the proposed EU definition from 2011. 50% or more of the primary particles in the space between 1 and 100 nanometers. The second one is the precautionary gate to enter the matrix. There by definition you have primary particles between 1 and 500 nanometers. If these definitions are true, then another question will be asked: does nanomaterial form agglomerates bigger than 500 nanometers? If this is no, then of course it's non-relevant. If yes, then another question will be asked: could these agglomerates deintegrate into primary particles again? If yes, it's non-relevant. If no, there the last question is asked, but this is true only for inhalable particles up to between 500 nanometers and 10 micrometers. And this is because if you have big agglomerates, they can have side branches in the nano size. For example, for powders or nanomaterials from grinding process from, for example, polymers with CNT. Now to the two other modules. That's the potential effect module. There you can see all the parameters used to calculate the reactivity. That's the redox activity, the catalytic activity, oxidative stress, and induction of pro-inflammatory cytokines. And also the stability in different media, for example, in the environment, but also, of course, in the human body. All these parameters for the reactivity, they are representing several modes of action of the nanomaterials. Concerning the exposure, the most important parameter is the physical matrix in which the nanomaterial is embedded. If you have polymer matrix, then the nanomaterials don't come out very easily from this matrix, and so the exposure is very low. Additional parameters used are the amount handled by workers or consumers per day, and of course the frequency of potential exposure. Concerning the environment, the additional parameters are environment from production, and also the annual amount of nanomaterials marketed in the consumer products. Now to the reactivity. That's probably the most complicated one. What you see here is from the guides document. This was produced already in 2012, and since then a lot of new studies were published. So I'd like to switch to a new table, which will be published hopefully soon this spring. And this table includes now also newer studies. And you can see it contains all the data are coming from the literature. You can see here the different test systems are separated into cellular reactivities and the calculated and acellular reactivity. And you can see the footprint of the different nanomaterials on the list are quite different. And what you can see is the rating. The low in medium is in yellow and the high is in red. How we did this rating, we had to rate every single study itself, because you can compare only within a study. So we have chosen only studies where several have been measured with the same methodology. This was necessary because all these assays, they have different sensitivities. So what we did as well is a comparison of these reactivities with in vivo studies. on lung toxicity. On the top, you see the comparison between the calculated acellular in vitro activities with acute lung toxicity. And just below, the comparison with the subchronic inhalation toxicity. And what you see is here the number of evaluated data sets. We only took the data when the set was really complete. And what you see here, the correct predictions are not very high. That's 8 out of 13. Here it's 3 out of 7. And what annoying is, of course, you will get quite a lot of false negative predictions. If you change now to the cellular reactivities, this is quite different. Here for the acute lung toxicity, it's 9 times of 12. It's a correct prediction. In one case, there is still a false negative prediction. But the prediction for the subchronic inhalation toxicity is quite good. That's 8 out of 8 is correct. And if you combine those two assays, the calculated and acellular with the cellular assays, then you get and you combine that with an OR, and then you get the best prediction. So it's 8 of 12 is correct for the acute lung toxicity and no false negatives. And for the subchronic inhalation toxicity, it's 8 out of 8. So what we did then is also a classification of these numbers, of these points you will get from this equation, from the equation I mentioned. So numbers between 0 and 20, they mean that there are no specific risk, and you can go on the market. But if the number is more than 20, you have to, risk cannot be excluded, non-specific risks cannot be excluded, and further clarification is necessary. And if necessary, you have to do a risk assessment. There are several documents on the precautionary matrix available. There is this guidance document. All I have said you can read also in this guidance document. And we have also produced a document with FAQs and responses. So if you have a question, you can ask us, or you can also look at that document. In this document, in guide document, there is also this checklist for users. This can be quite practical. It goes through the different steps to be followed. And maybe I can go here just to the important ones. The most important one is the one, it's draw up an inventory of materials, products, and application of the value chain you are evaluating. And then maybe the fourth one, decide for which steps a matrix has to be completed, because for each step you have to make an own matrix. Then point 6, if you have lacking information, you have to get this information. And point 7, if you have all the information that are needed, you can finish the matrix and localize the precautionary needs. And at the end, as a conclusion, you can clarify the need for actions. This can be look for further clarifications, look for more tests, protection measures may be needed, and measures to provide information to the consumer may be also important. So the precautionary matrix, there is also one recommendation how to use the matrix. The recommendation is that you should use the matrix in 2 iterative steps. A first rapid evaluation demonstrate the knowledge gaps and uncertainties, then you can get the lacking information. And if you have that, you can go to the matrix as well and fill the gaps in, and so you will get the final results of the evaluation.